Okay, this is the video lesson for Algebra 1B, section 4.4, graphing a function rule. So the objective here is to graph equations that represent functions. So for the first one, it asks, what is the graph of the function rule y equals negative 2x plus 1? Well, for this, we know it's linear. We know it's a line because of the format, but we'll actually learn that later. So maybe let's say we don't know that it's linear. We're just going to put some values of x, plug in our values for y, get some coordinates, and then plot them. And then with enough information, we can graph it. So let's start with 0. 0 is always an easy one to start with. This means we're going to write this as negative 2x plus 1. So we're going to plug that 0 in for x. So this is negative 2 times 0 plus 1, which is 0 plus 1 is 1. So this point is going to be 0, comma 1, which is right here. Okay, and then let's move maybe here to 4. Let's do 4. Negative 2 times 4 plus 1 is negative 8 plus 1, which is negative 7. So this becomes 4, negative 7. So down 4, 1, 2, 3, 4, 5, 6, 7. And then let's go maybe here, negative 2. This is negative 2, this is 0, this is 4. Negative 2 times negative 2 plus 1 is 4 plus 1 is 5. So this was going to be negative 2, comma 5. 1, 2, 3, 4, 5. Okay, and then I think it's going to be a line like this. And why don't we just pick one? Maybe we just to double check that this is right. Let's put in 2 and see if we get negative 3. Let's plug in 2. Negative 2 times 2. Plus 1 is negative 4, plus 1 is negative 3, just like we thought. So this is this is a graph for this. Okay, so try this next one on your own. You want to choose about at least 3 points. Always start with 0, that makes it easy. For this one, since it's a fraction, pick an even number, because this is just 1/2 times that. You just kind of break it in half, right? If you put a 6, 6 times half is 3, just divide it by 2. So maybe just put even ones in, and then see if you can get the graph. Press pause, check back for your solution. Okay, so hopefully you got this line here. I plugged in the same values here, 0, 4, and negative 2. And I got these points, I plotted them, I drew my line, and then I guessed, I think there should be one at 6 too. So I plugged in 6, and I got 2. So that was my check there. Okay, moving on. So this one is a word problem. Here we have a function rule where the W is the total weight and C is the cubic feet of concrete in a concrete mixer truck. So what's a reasonable graph for this function that if the capacity of the truck is about 200 feet cubed? Okay, so this one we're going to just be dealing with the positives. All right, so quadrant 1. And then this is saying, let's see, the independent variable is C, so that's going to be on the bottom, and then W is going to be on the left. So the capacity is about 200 feet cubed, so we can't go more than 200. So let's make this 200. That's 100. Oh no, not great. Hold on. All right, I fixed that. So cubic, the lowest it could be is 0, right? So C is going to be between 0 and 200, which means the weight is going to be between, when you plug in 0, so let's do that. Let's start our table, right? Our weight and our capacity. If our weight is, oh no, sorry, I did it backwards again. Remember, your independent variable goes here. So capacity and weight. Weight is dependent on capacity. So if we start at 0, right, if you plug in 146 times 0 plus 30,000, you get 30,000. Okay, so we have this point here. And so let's make this start at 30,000. All right, then that's where this graph is going to start. Okay, and then the highest it can go to is 200. So let's plug in 200. When we plug in 200, we get 59,200. So let's just put that, let's make this, it has to get up to 60 then. 4, 5, 6. Okay, so here I made it 3 of these 10,000. So we have our 30 to almost 60 here. Okay, so we have a graph that's going to fit this. And so we have another point here that's 200, 59, 200. So that's going to be the highest point here. Maybe something like that. And then this is going to be, let's see, maybe 100. Let's plug in 100 here. 146 times 100 plus 30,000. And that is 146. So this would be 44,600. So 144,600 is about here. And I think that's enough, right? Looks like it's a line. And this one stops here, right? This is the lowest it can be. It can't go below that, so we're not going down here. And then it can't go more than that, right? Because this is the capacity. So it's just this graph here. There's your graph. Okay, so try this next one on your own. Make sure that you have the right stuff on your axis. That's the hardest part, right? That you have the numbers that you need on the y-axis, the numbers you need on the x-axis. Okay, so press pause, try this on your own, and check back for the solution. Okay, so here if you put in 0, you got 700, you put 250, which is the capacity. You get 2,700, so you want to make sure you have from 0 to 3,000, about 3,000 on this side. And so you have these 2 points when you plug them in, and then I picked this one in the middle, and I guessed somewhere around here, and then when I put it in, it was about 1,900. So there's your graph. Starts here, ends there. Okay, moving on. All right, so what we just created were continuous graphs, and that's when the line just goes forever one way or the other. And even in the one before, it was continuous. It was continuous in between where it started and it ended. A discrete graph is composed of distinct isolated points. And then so coming after this, you'll see some examples of discrete graphs. So in this first example, it's a word problem. It says local cheesemaker is making cheddar cheese to sell to farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation, graph the function, and is the graph continuous or discrete? Okay, so I set up these graphs first. Oh, actually, I didn't set up this one. Right, let's make these each 16, 32, 40. Okay. This is saying a gallon of milk makes 16 ounces of cheddar cheese. So the cheddar cheese is dependent on the number of the amount of milk. So milk is my independent variable. So 16 times gallons of milk, M is however many ounces of cheddar cheese. So this is in ounces. And then in this one, it says each wheel of cheddar cheese costs $9. So however many wheels you have times 9 gives you the dollars. So this is a different C, but this is a wheel of cheese. And this is dollars. Okay, so we have our graph set up. And so this is by ones, this is by 16s, this is by 9s, and this is by 1s. Okay, so this is saying 1 gallon of milk makes 16 ounces of cheddar cheese. Well, 0 makes 0. Every time you have 1, you get another 16. So that's why I set it up like this. And then for this graph, right, I have these points. 1 gallon gives you 16 ounces, 2 gallons give you, but can you have half of a gallon of milk? Yeah, you can, right? You can have any amount in between, and this is how many ounces of cheddar cheese it's going to make. Okay, so this graph is going to be continuous. This actually probably keeps going. This is continuous because you can have part of a gallon of milk. And you want to just think of like your independent variable. Can you have part of that? You can have part of a gallon of milk. Okay, so that's what makes it continuous. So that means here, this is saying if I have 2.5 gallons of milk, I'll make 40 ounces of cheddar cheese. So it's in between these dots. Now for this one, this is going to be a little bit different, right? This is saying each wheel of cheese costs $9. So 0 would be 0, 1 would be 9, 2 would be 18, and so on like this, right? And so now to figure out if it's continuous or discrete, wheels of cheese. Can you have part of a wheel of cheddar cheese? I guess technically you could. But let's say at this store, just to make things easier, the store only sells each wheel of cheese. It's not going to cut a cheese in half and give you a half of a wheel, okay? And so in that case, there is no, right, you can't have 1/2 and get a value, or like 3.5, right? That's why you can only have whole number wheels of cheese. So that's why there's a dot at every whole number. And that's why this is discrete. And it's because you cannot have part of a wheel. Can't have part of a wheel of cheese, okay? And hopefully that will give you a better example of why continuous and discrete means. So here's an example for you to try on your own. Graph each function and then figure out if it's continuous or discrete. Okay, and then press pause, do this, and then check back for your solution. Okay, and then here are the graphs. So here's the graph of A. Right here's the water in the wading pool. This is the time it's been filling. And this is going to be continuous because it can have a part of a minute. Right, and I just plugged in 1 and then 2 and then 3. That's where I got those dots. But this is the graph, right? This is the part you have to think about time. Can you have part of a minute? Yes, you can. So at 30 seconds, right here, right, it's filled up, 1.5 gallons. Right, so this can be on the graph. So this is continuous. For B, it's saying the cost of baseball tickets depends on the number of tickets bought, right? So if everyone's $16, this is my graph, right? 0 is 0, 1 is 16, 2 is 32, and so on. Can you have part of a ticket? Here's my half a ticket. Half of my body is going to go to this baseball game, right? No. So that's why when you go to a half, there's nothing there, right? It's actually not on the domain. We'll get to that later. But this is discrete. This is called a discrete graph because it has, let's use the actual terminology. It is composed of distinct isolated points, whereas continuous graph is unbroken. Okay. And now, last one for you to try. These are not linear, so these are a little bit different. Okay, so for these, we're going to make a table as well. Let's do 0, 4, and -2 again. And let's plug this in the absolute value of x minus 4. That's my y. So absolute value of 0 is 0, minus 4 is -4. So we have a point 0, -4 here. Absolute value of 4 is 4, minus 4 is 0. So we have 4, 0. That goes here. And then -2, the absolute value of -2 is +2, minus 4 is -2. So -2, -2. And then you can keep plotting, just pick more values until you can get the shape. I know what the shape's going to do, so I'm going to stop here and show you. But, I don't think this doesn't, you don't know if this goes down here, up here, or what. So you might want to just fill in some of these points here. And what's going to happen is you're going to get a V. Because that's what absolute value graphs look like. But you just find values of x, plug them in for y, and then plot the points, and then follow the dots until you get pretty confident in your shape. Okay, and then this one is going to be a parabola because it's squared, but you haven't gotten there yet, so let's just see what happens. Let's plug in as many as we can. Let's do -4, -2, 0, 2, let's do 0, 1, and 2. And see what happens. This is x squared plus 1. So this is -4, which is squared is 16, is 17. And then -2 squared is 4 plus 1 is 5. 0 squared is 0 plus 1 is 1. 1 squared plus 1 is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. So we have -4, 17. 2, 5, 0, 1, 1, 2, 2, 5. All right, this one I don't think is going to be on the graph, so let's skip that one. -2, 5, 2, 3, 4, 5, and then 0, 1, and then 1, 2, and then 2, 3, 4, 5 here. And you can kind of see, and as you go, if you filled in, right, if you did -4, it's going to be all the way up here. Actually, maybe if it's 5, 10, 11, 12, 13, 14, 15, 16, something way up here. Okay, so it's going to look like this. And you can keep picking to plot them in. But this is going to be a U. Okay? So try this last one on your own. Try as many points as you can. Do some here and here too. Make sure you do some negative, some positive, and 0. And see what graph you come up with. Press pause first, and then check back for your solution. And then we'll be done. Okay, this one's kind of hard unless you really know what it looks like, but look at that little squiggle there. I just plugged in -2, -1, 0, 1, and 2, and got these points. Plotted 1, 2, 3, 4, 5 points, and then just kind of connected the dots smoothly. That's your x cubed plus 1. Okay, here are your numbers to try. Enjoy.